For Unit 5, Lesson 3, we will be discussing entropy. In a previous lesson, we discussed the first law of thermodynamics, that energy cannot be created or destroyed. The second law of thermodynamics states that natural processes tend to move towards a state of greater disorder, or greater entropy. The second law tells us what will happen spontaneously or without any outside intervention. So a spontaneous process is a process that can proceed without any outside intervention. So the reaction happens naturally. For example, if you leave ice sit out on the counter, it's going to spontaneously turn into water. Entropy, symbolized with the letter S, can be thought of as a measure of the randomness or disorder of a system. We can increase a system's entropy by increasing temperature, volume, having more molecules present, having larger molecules present, or having more degrees of freedom. Gases possess the most entropy. A spontaneous process will have an entropy greater than 0, or a positive number. A non-spontaneous process will have an entropy less than 0, or negative. Let's try example number 1. Of the following, the entropy of blank is the largest. So again, we said the more degrees of freedom, so gases having more entropy, should eliminate some of our choices. Then we want to look at size. So HI should have the largest mass. For example number 2, we are again asked to find the molecule that has the largest entropy. Since they are all gases, we then want to look at the mass. So D, C2H6, should have the largest molar mass of the 4 choices. When predicting entropy changes, there are 3 rules we want to look at. First, we want to look at how the phases of the reactants and products are changing. Our entropy should increase if we're going to a higher phase, for example, liquid to a gas. Our entropy should decrease if we're going to a lower phase, for example, a gas to a solid. Our second rule is we want to look at the number of gas molecules on our reactant to our product side. If the number of gas molecules increases, our entropy should increase. If the number of gas molecules decrease, our entropy should decrease. And if there is no change, then our entropy will stay the same. And finally, our third rule, if we are still unable to determine how our entropy is changing, we want to look at the number of moles of molecules on our reactant to our product side. If the number of moles of molecules increases, our entropy should increase. If it goes down, our entropy will decrease. For example number 3, we want to find a process where our entropy decreases. So we're looking at phase changes for this one. So we want to find a phase change that goes from a higher state to a lower state. Example, gas to a liquid. For example number 4, we are again looking for a decrease in entropy. So pause the video and see if you can determine which of these has a decrease in entropy. For example number 5, we are looking for a positive delta S, or an increase in entropy. Put together rules 1 and 2 to determine which of these would have a positive entropy. And repeat this same process for example number 6. Find a system that has a positive entropy, or increasing disorder. So spontaneity of a reaction is not only affected by our entropy or delta S, it is also affected by the enthalpy or delta H. So Gibbs free energy is our third quantity that helps us to determine which reactions are favorable or thermodynamically spontaneous. So the Gibbs free energy equation, delta G, measured in kilojoules, is equal to our enthalpy, again measured in kilojoules, minus T delta S. T standing for temperature measured in kelvins, and entropy, delta S, measured in kilojoules. Having a negative delta G means our reaction is favorable or it's spontaneous. If our delta G is 0, means our system is at equilibrium. And if our delta G is positive, it means our reaction is non-spontaneous, or the reverse reaction is spontaneous. For example number 8, we are asked to calculate the value of delta G. We want to use our equation and plug in our numbers. Double check that all your units are correct before you plug them in. For example number 9, we are looking for a reaction that is spontaneous, meaning our delta G has a negative value. So we need to figure out what H and S have to be to always give us a negative number. So delta H being negative and S being positive, H minus S will always be negative. For example 10, we are asked to do the opposite. Which of these reactions will always be non-spontaneous? So we'd like a delta G to always be positive. So to get this, we would want to start with a delta H being positive, and then we want to subtract a negative delta S. So H plus S will always be positive. For example number 11, we want to find a reaction that is non-spontaneous when our T is a small number, but becomes spontaneous when temperature is a high number. So to get a negative G for this situation, I'm going to have a positive S and a positive H. Here, T, when it becomes large enough, will be subtracting a big enough number to become negative. Example 12, we want to look for clues in the paragraph to help us determine the signs of our delta H and delta S. So our entropy, we want to look at temperature. Our temperature decreases, meaning it's an endothermic process, a positive delta H. For delta S, we go from a solid to an aqueous substance, increasing disorder, positive delta S. And that's another AP Chem lesson with Miss Gates. Make sure you hit the like button, tweet me at Miss Gates Science, and I'll see you for the next lesson.